Hello friends, good afternoon and welcome to Reset Live Lectures. Dear friends, today in phase equilibria, we will be talking about phase diagram of two component system. It will be the part 2 of the continuing lecture on phase diagram of two component system. To discuss this topic, we have with us our subject expert Dr. Amit Kumar. Dr. Kumar is Assistant Professor in Department of Chemistry in Dayal Singh College, University of Delhi. Without further ado, I would like to welcome sir to our studios and request him to start the lecture. Welcome sir.
Thank you, Amrit. Dear viewers, first of all, I wish very good afternoon to all of you and to this second lecture in phase diagram of two component systems. We shall try to understand where we can apply the knowledge which we have gained till the point of time for phase diagrams of one component system in real life experiences, where we can apply this knowledge. So let us have a look at this. You must be knowing that earlier days in electronic industry, where we used to make transistors, integrated circuits, onto which the diodes, triodes or semiconductors were used to be placed in the circuit, and they used to be stitches in the electronic circuit used to be made, and that was made by virtue of a soldering alloy. What a soldering alloy or a technician, electronic technician used to do is that he used to have a soldering material with him, that is an iron rod which could be hot at one end by virtue of application of electric energy, and when that hot rod which was made of iron was used to bring to a metallic wire. That metallic wire is basically fused with some cream to it, and then it used to solder the electronic circuit. Now the question arises, what is the chemistry behind this whole soldering of metals, or can we look at this observation, look at this application in terms of our knowledge which we have gained in phase diagrams of two component system. We shall come back to this discussion. First, let's first of all look at the phase diagram of two component system having lead and antimony as two different components. Both these components do make a simple eutectic system, as you can see in the phase diagram. Antimony having its melting point at 631 degrees Celsius, whereas the melting point of lead is 327 degrees Celsius. This is the phase diagram. If you look at it, we could have made it by virtue of a cooling curve or theoretically also. Now, from the phase diagram, it is very clear that pure lead melts at 327 degrees Celsius, where this pointer is pointing out to you in the figure, and 631 on the antimony axis represents the temperature at which the antimony undergoes melting. Now, there is a eutectic also. Eutectic lies at 241 degree Celsius. 241 degree Celsius. There is eutectic. And what is the mass percentage? Mass percentage is antimony is in lesser proportion and lead is in greater proportion. So, it is very close to the 100% axis of lead, but it still is away from it, and the eutectic exists at 246 degrees Celsius temperature, at lower temperature. So, what they used to do is they used to have lead and antimony fused together, mixed together, and then heated with the iron rod, and that wire used to contain these two metals. And now when the soldering metal alloy just heats the content, heats it, the rod heats it, then it leads to melting of that alloy, that is of antimony and tin, which is being made at eutectic composition at a much lesser temperature compared to tin or compared to lead. Both has greater temperatures. So, because of addition of antimony lead, its melting point gets decreased and leads to only 246 degrees Celsius. This is sufficient enough at which this operation can be made of soldering of the electronic circuit without keeping the electronic circuit intact. So, at a much lesser temperature, it can just bring about connections between the 2 points where there is the connection has been lost on the electronic circuit. So, this is how the application of alloys, that is alloy of antimony and lead, can be thought of. That is where you can solder the electronic circuit with the help of a metallic wire which undergoes melting at a much less temperature than the metal which is already present on the electronic circuit. That is what is the real time good thing about it, of this application being envisaged, and this can be explained with the help of phase diagram of two component system. Now, we switch on our attention to another very important application. You must have seen that when we go to snow covered hilly areas in winter season, the roads gets covered with snow, and you must be knowing that salt is sprinkled on the snow covered roads, that is on the heaps of snow, salt is sprinkled, and thereafter the ice is removed with the help of the crushers. That is the usual procedure which is being followed on snow covered roads in hilly areas. Now, another observation you can think of, you must be knowing, you must have relished at some point or the other some conventional kulfis, where you must be knowing that the ice cream vendor who used to vend ice creams, the conventional kulfi, basically that is placed in a iron block, and in that iron block he used to fill the batter which has been made of milk, and once the batter has been placed in the iron block, he introduces a wooden stick to it and then place it in his box which is made up of wood, and inside the block, inside the wooden block, what is the content, that we need to investigate at this point of time, because it is important to note that when the ice cream vendor pours the content in just quick succession, just about 5 minutes time, it leads to immediate preparation of kulfis. That is too quick a time limit in which freezing can be brought about. Even in our refrigerators, it takes about an hour's time for ice to make. So, the question is, can these two observations be explained with the help of phase diagram of two component system, or what the role the salt has to play while sprinkling on snow covered roads, and what the role salt has to play, what the salt has to do with the ice cream vendors vending wooden box. So, let us take these observations one by one. And before we take these observations, let us first of all look at the phase diagram of water and sodium chloride. You see, water has melting point that is 0 degree, that is 0 degree Celsius. So, you can see on water axis the melting point has been placed at this point A, which is 0 degree Celsius. Now, sodium chloride melting point would be more than that of 1000 degree Celsius. So, this is beyond this range. So, you can see this liquidus curve for sodium chloride is moving upward, and will somewhere it will take turn and ultimately lead to meeting with the axis which is meant for sodium chloride. So, it is very clear that when sodium chloride is added in ice, so it may result at some 23.3 mass percent of sodium chloride, that is for every 100 gram of the mixture, if 23 gram is sodium hydroxide, sodium chloride, and rest is water, that is to say about 75.7 exactly per mass percent of water. That means if we take 100 gram of mixture of water and sodium chloride, this mixture, if it has 23.3 mass percent gram mass of sodium chloride and 75.7 gram of mass of water, then in that situation this mixture can be called as, would be called as eutectic mixture. As you can see in the phase diagram of water and sodium chloride, this point where the pointer is pointing, this represent the eutectic point, which represent eutectic composition and eutectic temperature also. It is very important to note that what is eutectic temperature? Eutectic temperature is minus 21.1 degrees Celsius. So it means this is the mixture which undergoes easily melting. Or what is eutectic temperature or eutectic point? Eutectic point we have seen in simple eutectic systems or any other system is that point at which there exists 3 phases in equilibrium with each other. One is solid phase of component A, other is solid phase of component B, and the third is the liquid mixture of both A and B. So this point E over here represent eutectic point, and therefore eutectic point represents 23 mass percent sodium chloride and 75.7 mass percent of water. So what, in view of this, what inference we can draw out of it is that if we mix water with the sodium chloride with water, its melting point can go up to minus 21.1 degrees Celsius. That is, if you mix sodium chloride corresponding to eutectic composition in water, then the melting point of that mixture would be minus 21.1 degrees Celsius. It does mean that if you have that mixture at 22 degrees Celsius, minus 22 degrees Celsius, even then it is in liquid phase. So it means water in presence of sodium chloride with this mass percentage, which correspond to eutectic composition in mixture, can exist in liquid phase even at minus 22 degrees Celsius. That is a very important observation which we can make from the, or important conclusion which we can make from the phase diagrams of water and sodium chloride, is that now the fact is, suppose you have a snow covered road in hilly area, and then when salt is sprinkled onto it, what happens is that earlier it was only pure water in solid phase which was present, so only one phase was present. When you have added enough sodium chloride, then what it try to do? Sodium, because of addition of sodium chloride, melting point of ice will definitely decrease. So when you continuously sprinkle sodium chloride, what will happen? System becomes unstable there. The solid ice cannot exist as such, because presence of sodium chloride would lead to dissolution first of sodium chloride in some of the water which would be present on the surface, which may exist because of excessive pressure which is being applied on the surface of snow. That pressure gets exerted by virtue of the pedalers or some people or some vehicle which are plying on that. Now when you sprinkle salt, what it try to do is try to dissolve, because the system is unstable. Solid ice cannot remain as such, it need to melt, because otherwise our phase diagram suggests that ice along with sodium chloride cannot exist at 0 degrees Celsius, it has to be in the liquid phase. So, therefore, system becomes unstable. In order to let the system reach the stable position, what it requires is that it requires that sodium chloride undergo dissolution, but for that it requires water. So, therefore, what will happen? First, the water in solid phase will undergo melting to the liquid water. So, it means there will be conversion of solid water to liquid water. So, now this conversion or phase transition from solid phase to liquid phase would actually occur with is an endothermic process. It would decrease temperature. Even though this process is spontaneous in nature. So, what will happen? This will lead to dissolution after the liquid is formed. Once the liquid is formed, the dissolution of sodium chloride will be occurring in this, and that would dissolution of sodium chloride is again an endothermic process. It would further lead to a decrease in temperature. Even though the temperature is decreased, but you will have the liquid phase now, and now therefore with the ice melting on its surface because of sprinkling of sodium chloride on its surface, which leads to first of all phase transition of ice, that is water in solid phase to liquid phase, and then in liquid phase sodium chloride undergoes dissolution process. So, in this manner we can say that in this process the ice can easily be removed from snow covered roads. That is why, because it undergoes melting. That is why salt is sprinkled on snow covered roads in hilly areas during snowfall season. Having said this we have been able to explain also from phase diagram of two component system. Coming over to the ice cream vendor. Now, the ice cream vendor which you come across, basically he has a wooden box in which he tried to put lot of crushed ice. It completely he completely filled his wooden box with crushed ice. First he crushes the ice, and that crushed ice is been placed in his wooden box, which is so densely populated that there is hardly any space in terms of gases or liquid. So, in his wooden box there is lot of ice. Now, to it he introduces a iron casing onto which iron blocks can be placed in that wooden box. So, now that iron casing which has been placed on the top, now in order to further add the iron blocks in this, what he tried to do is he tried to add little bit of water to it also, so that a equilibrium get established between solid and liquid phase. So, little bit water is also introduced. Now, thereafter what he tried to do is he tried to add a lot of salt to it. Now, question arises, what is the purpose of having this salt there? We will get to understand very shortly. When we go to when he try to add salt, he has his ability to decrease the temperature to near about minus 20 degrees Celsius, minus 22 degrees Celsius or so. He has acquired this ability just because of the fact that he has been making this wooden block over a long period of time. So, he has got this experience, and he knows that how much salt is required in his wooden box depending upon the mass of the ice which he uses. So, basically what he tried to do is he tried to achieve the composition of the mixture as minus 23.3 mass, near about 23 mass percent of sodium chloride. That is, for every 100 gram of the mixture, what he used to have is he used to roughly has 76 gram of ice, and to it 23 gram of sodium chloride roughly he mixes. Now, in this once the mixture is made, this mixture is called freezing mixture. Why this mixture is called freezing mixture? I would like to explain it to you. This mixture is called freezing mixture because how many phases? Now, if we want to understand why this mixture is called freezing mixture, we need to understand how many phases are there when such a mixture is being made. There is sodium chloride in solid phase, there is water in solid phase, there is liquid water which you had added. So, liquid phase, solid sodium chloride, solid water, 3 phases exist. Now, these 3 phases which do exist, in order to have these phases in equilibrium, we must be at eutectic point, because in phase diagram of 2 component system having water and sodium chloride in it, it requires that 3 phase can exist only at eutectic point, and eutectic point is the temperature that is minus 21 degree Celsius. But when such a mixture was prepared? Such a mixture was prepared at room temperature. So, at best the mixture temperature could be near 0 degree Celsius, because ice is at 0 degree Celsius. So, when we have added these components to result to the desired mixture, this mixture has 3 phases and can get stable, can exist only when the temperature is minus 21 degree Celsius. So, it means system is unstable at this point of time. When the system is unstable at this point of time, what it does mean? It does mean that the system requires stability, and we will talk about how the system acquires stability in our next module. Thank you. Alright, in this module we will try to see how the system which is basically a mixture in which sodium chloride and in solid phase, solid sodium chloride, ice, crushed ice and liquid water is mixed. Basically when these 3 things are mixed, so as I have told you in my previous module that this mixing would lead to presence of 3 phase. One is solid sodium chloride and solid water, along with it there will be liquid phase. Now, this system cannot remain stable, this would be unstable and it would lead to acquire stability. So, therefore, this system would not be at equilibrium. It would try to undergo some modification to reach to the equilibrium position, and in order to reach the equilibrium position, what it requires? To decrease the temperature of the system. Now, how the temperature can be decreased? There are 2 ways. Either this solid ice that is water in solid phase which we had taken, it should melt. When this melts, then what happens? This requires heat, and if the system is adiabatic in nature, it would not allow heat to enter from the surrounding to the system or to let the heat to go from system to surrounding. Then in that situation when heat is not allowed to enter the system or to move out of the system, then when ice undergo melting, then it leads to formation of liquid, and it utilizes the thermal energy of the system, and it would lead to a decrease in temperature of the system. So, it means melting of ice would lead to a decrease in temperature of the system if the system is adiabatic in nature. Now, when it further undergo melting, then what happens simultaneously? There is sodium chloride which exists in solid phase that undergo dissolution. So, dissolution of sodium chloride in liquid water so formed also undergoes simultaneously. That is also an endothermic process. So, that will because that is also an endothermic process. So, therefore, it also requires the heat. So, it will also once again decrease the thermal energy of the system itself, and then when the thermal energy of system decreases because of these two endothermic process, the one is melting of ice and the other is dissolution of sodium chloride, then it would lead to immense decrease in temperature of the system. And now this dissolution can go on and on up to a temperature that is minus 21.1 degrees Celsius, and that is basically the eutectic temperature. That is basically the composition of the whole mixture, that is 23.3 mass percent sodium chloride, which we had already made it, which we had already made. So, therefore, such a mixture which would be present would continuously be there, would continuously remain at equilibrium position once temperature of minus 21.1 degrees Celsius is reached. Now, if suppose we had not added so much of sodium chloride, so that it could lead to the dissolution of sodium chloride and simultaneous melting of ice, then it would not lead to the final temperature, that is minus 21 degrees Celsius, and the system would once again acquire equilibrium position there. But the point is that can we create such an adiabatic system which would lead to complete insulation of the content of system from its surrounding? It is not possible. We can at best create an adiabatic wall or an adiabatic system which can be at most, at best can be near adiabatic, but we cannot create a perfectly isolated system. So, heat would still flow from surrounding to the system, but the rate of heat flow we can control, we can decrease as much as we can. So, it would lead to a near adiabatic system, and therefore, in this manner we can create a pool or a bath or a system whose temperature can reach minus 21 degrees Celsius by making such salt water mixture. So, therefore, such a mixture is called freezing mixture. Why freezing mixture? Because anything what you go to add which has melting point between 0 degree and Celsius and minus 21 degrees Celsius, it is going to freeze very quickly. That is exactly what occurs in the system which is of an ice cream vendor, the kulfi wala. What he used to have is, the ice cream vendor has a wooden box in which he tries to insulate the wooden box from the inside wall as well, and now thereafter he tried to put a lot of ice there, crushed ice in it, and also add lot of sodium chloride, so that the total composition of mixture is near about 20 to 23 mass percent sodium chloride, and a little bit of water he also adds. And then, as I have already explained, there will be, the system would now have 3 phase, and it would be in unstable state, and in order to reach to stability, the system require that the continuous melting of ice occurs, as well as continuously dissolution of sodium chloride also occurs, and both these processes occurs in it. And as he has tried to make his system adiabatic, so it utilize it both endothermic process use the thermal energy of system, and temperature of system continuously decrease. And if you have made eutectic composition, a mixture corresponding to eutectic composition, then of course it would lead to a decrease in temperature, that is minus 21 degrees Celsius, minus 21.1 degrees Celsius can be reached. So, now at such low temperature which he has in his wooden box, now when he places a iron casing on which iron blocks can be placed, he has long iron blocks which has hollow space in which the batter of kulfi can be placed, and that is what he tried to do. He tried to place all those iron blocks onto the iron casing. These gets immersed in the freezing mixture bath, that is wooden casing. Now, in this, when he tried to put ice cream batter on in the liquid phase in each and every iron block, and he tried to introduce a wooden stick to it. Now, after just a 5 minutes time interval, what happens? Heat goes from the content of iron block, which contains basically the ice cream batter, which is being maintained at room temperature. The heat flows from this inside batter to the iron block, then iron block transcends that heat in the form of thermal energy to the freezing mixture, and therefore freezing mixture temperature undergoes an increase a little bit. Earlier, if you had made a freezing mixture at minus 21 degrees Celsius, so because of this transfer of heat by virtue of ice cream batter, it would lead to an increase of the freezing mixture which has been present in the wooden block, but it would not be much, that is about minus 1 or 2 degrees Celsius increase, and still be very cold. This whole wooden box would be very cold, and in which when he try to put batter, quickly he gets relishable ice creams or kulfi in the solid phase. That is very so interesting. If you would have made some observation that vapors of water also you do observe when you get the kulfi in your hand, ice cream in the hand. That is because that is maintained at very low temperature, and a direct sublimation temperature has been reached, and direct sublimation of solid phase to vapor phase continuously occurs. So, therefore, in this manner the ice cream vendor try to operate his whole business the whole day. It means he can let this wooden box stand for about 4-5 hours. That is what usually occurs, and you would have seen that in 5 hours these ice cream vendor used to come at the evening time when the people try to relish these kulfis, and then they take it and it runs up to late night. So, near about 5-6 hours. So, this is what and very interesting application of phase diagram of two component system, where we had seen phase diagram of water and sodium chloride, and how these very easily available material can be used to create freezing mixture up to minus 21.1 degrees Celsius, and how freezing can be achieved of ice cream batter to make relishable ice creams in this manner, even along roadside without consumption of any electricity or electric energy. And this you can still regenerate. This is you can still regenerate. That is because when you have this whole wooden box which contains this mixture, once it get liquefied, you can take it in iron container or any other container, and you can place the whole container in sunlight and let this evaporation of water goes on, and once again you can generate your sodium chloride, and then once again you can make use of this sodium chloride by virtue of again adding to the wooden box containing ice, and once again you can achieve such freezing mixture. So, therefore, this is sustainable business model can be achieved. Only thing is one crushed ice is required by an ice cream vendor. Alright, so after this we try to with these two applications which we have been able to discuss, now we switch on our attention to phase diagram of two component system having formation of congruent compound. What is a congruent compound and why compound formation occurs? You see, sometimes it is possible. For example, I give you an example. Sodium sulfate is in anhydrous state, that is sodium sulfate Na2SO4, and there is water also. When it is mixed with water, it would crystallize in the form of shiny crystals, then these crystals would be having different water of crystallizations, and maximum at best you can go to 0.5H2, Na2SO4 0.5H2O, that is sodium sulphate pentahydrate. So, it means a compound, we can say a compound is being formed, that is if we treat sodium sulphate as A and we treat water as B, then the compound AB5 is being made if you have made sodium sulphate pentahydrate. Similarly, copper sulphate crystals you would have seen, copper sulphate shiny crystals of hydrated salt, that is CuSO4 copper sulphate pentahydrate. So, which has 5 moles of water of crystallization for every 1 mole of copper sulphate being crystallized together with water. So, these are called hydrated salts, and the sodium sulphate copper sulphate pentahydrate also has if we say copper sulphate called as A and water called as B. So, it form compound AB5, and they can also make compounds in different proportion AB2, AB3, AB4, AB5 or A2B, A3B or whatever. In this manner, if we go to mix two components, then upon going to the liquid phase, when it crystallizes, it lead to formation of some compounds of this sort, which can also undergo decomposition upon heating, excessive heating, even beyond their melting point. So, having said this, or even below their melting point also, this can undergo decomposition. So, now it means compound formation can occur in this manner, and compound formation is of two type. One is that kind of compound, suppose we have made a compound AB2. AB2 means 33 mole percent of A when mixed with 66 mole percent B, it would lead to formation of compound AB2. And this compound AB2 once get formed, when you have this compound in the crystallized form, in the crystal form, in the solid phase, then when you heat this compound has a characteristic melting point. Melting point of a compound is the temperature at which the solid phase comes in equilibrium with liquid phase. Now, if this melting occurs at a fixed temperature and the whole compound can undergo melting at this temperature, the compound is said to exhibit sharp melting point. More important is the fact that when this compound undergo melting, then the liquid which gets resulted also has the same composition. That is to say, if AB2 is the compound which is in solid phase, that is also comes in liquid phase, that is also coming in liquid phase in the same identity of the chemical constituent, that is AB2 is still there, but is present now in liquid phase at its melting point, and the whole of the solid can undergo melting at this temperature only. Such a compound is called a congruent compound. Or in other words, a congruent compound is the one which undergo melting to lead to liquid phase having the same composition as that of the solid phase. That is the point. Now, there is other set of other kind of compounds also. Suppose you made a compound A2B or AB2 or whatever, any compound in any proportion, when A and B mix go to form a compound, let us say AB2. Now, this compound, instead of when is crystallized and when is heated, then it would acquire greater temperature and ultimately lead to it will reach a temperature at which you will observe formation of liquid phase. But if this formation of liquid phase occurs with the condition that the composition of solid phase and composition of liquid phase is different. When the composition of these two phases are different, then in that situation we would say the compound which had formed or which you were trying to heat is a compound which is not a congruent compound, is an incongruent compound. Incongruent compound means the composition of solid phase which when get heated undergoes melting, but undergoes melting with composition of liquid phase different from composition of solid phase. Such kind of melting is called incongruent fusion. And it is important to note that why such incongruence, why such difference in composition occurs? This occurs because of the fact that the compound which you were heating at this temperature has undergone decomposition and has led to formation of either another compound in solid phase or some pure component has been formed from this decomposition in solid phase, and in addition some of the liquid phase having either other component or some other proportion, having some other proportion of these two components is being achieved. So, in this way the composition in solid phase and liquid phase are different in incongruent fusion. This incongruent fusion is also called peritectic reaction. Peritectic reaction, why this incongruent fusion or this fusion process is called peritectic reaction is because this contains two words, peri and tectic. Tectic means melting, peri means a melting process in which the compositions are not the same of the solid and liquid phase which do results from melting of the compound. So, till this point of time about the compound formation we have cleared ourselves that when two components are mixed and they form a compound, this compound can be formed in a fixed definite proportion, and this compound may not be stable up to its melting point or may be stable up to its melting point. If this compound is stable up to its melting point and lead to formation of liquid phase of same composition, then this compound is called congruent compound. If the compound undergoes decomposition prior to reaching the melting point, then the compound undergoes incongruent fusion, and this called peritectic temperature or the incongruent temperature also. Now, with these two features, the phase diagrams of two component systems having two components can be classified differently. One as phase diagram of two component system having formation of only congruent compounds, and one as phase diagram of two component systems having formation of only incongruent compounds, or they can also be formation of some congruent compound or some incongruent compound. And we will discuss about the formation of these two kind of compounds and phase diagrams of various systems which has the formation of these two different kind of compounds in our next module. So, thank you very much.
Dear friends, on that note, we would like to thank Dr. Kumar for coming to our show and delivering this wonderful lecture. And thank you, dear friends, for watching our show. Stay tuned and keep watching. Thank you.